Good day to everyone. I'll be discussing our life cycle assessment on the production of cement and its corresponding wastewater treatment plant and materials recovery facility. The cement industry is perhaps one of the largest and significant industries today. The industry is capital intensive, with the establishment of a plant requiring a long turnover time. It is also energy intensive, requiring large amounts of fuel for its production process. The process involves the excavation of natural minerals found in the ground. Countries are trying to achieve economic growth and sustainability, and with these come a high necessity for infrastructure and highways. Large business companies heavily rely on cement for the establishment of their facilities like malls, stores, and manufacturing plants. As a result, the cement industry experiences a very high demand on its products, being a key to the development of the nation. The Philippines is considered as a developing country, and its economy is considered as one of the largest among the Association of Southeast Asian Nations members. The rise of its economy entails the heavy necessity for buildings, infrastructures, and roadwork, since the economy is majorly reliant to the tourism and agricultural products in need of transport. Currently, the Cement Manufacturers Association of the Philippines has 6 members. These members have a total of 16 cement plants scattered across Luzon, Visayas, and Mindanao. The Philippines, having a land mass with an abundance of minerals, is ideal to the cement industry. The impending rise of the economy of the Philippines and its transition from an agricultural-based economy to an economy based on manufacturing will pave way to the success of the cement industry in the years to come. In the production of cement, a crusher is first used. A crusher is a machine that is designed to reduce boulders into smaller rocks, gravel, or rock dust. Crushers may be used to reduce the size or change the form. For cement production, the limestone rocks that came from the limestone quarry will undergo the crusher machine so that the rocks will be crushed and reduced into smaller ones. The resulting rocks from the primary crusher are still rough ground limestone. To ensure the production of a fine ground limestone, the resulting ground stones from the primary crusher are then passed through a secondary crusher. The third process will be under the proportioning equipment. In the proportioning process, other raw materials will be added to the materials being used so that the exiting product from the process will contain the desired amount of each material given the property that they can contribute to the overall product. In the cement production, the fine ground limestone that entered the proportioning equipment are mixed with fly ash, iron silica, slag, and calcium that were delivered by truck. The resulting exiting products is a mixture of sand, limestone, and clay. The mixture of sand, limestone, and clay that exited from the proportioning equipment will now enter a grinding mill. A grinding mill is a machine that breaks solid materials into smaller pieces by grinding, crushing, or cutting. A grinding mill is used because the materials added to the fine ground limestone may still be in chunks, which are not desirable. Given the physical nature of the desired cement, the sand, limestone, and clay mixture will go through a grinding mill so that they will obtain a fine powdery-like texture. After going through the grinding mill, the raw meal will then undergo the preheating tower and the kiln. A kiln is a thermally insulated chamber, a type of oven, which produces temperatures sufficient to complete the cement making. In the production, the blend raw material enters the kiln via the preheating tower. In the preheating tower, hot gases are used to heat the raw meal. As a result, the raw meal is already hot before it enters the kiln. The preheating tower provides a series of cyclones in which fast-moving hot gases keep the meal powder suspended in air. All the time, the meal gets hotter and the gas gets cooler until the meal is at almost the same temperature as the gas. In general, the hot gas from the kiln are blown through the cyclones. In this case, heat is transferred efficiently from the hot gases to the raw material, and this minimizes the waste of fuel when the meal already undergoes the kiln itself. The exiting meal from the kiln is now called a clinker, which is the basic material needed to make cement. The clinker will then pass through the clinker cooler to have the clinker cooled. Now, along the process of cooling, the heat energy from the clinker can be recycled and used again for the heating process. Therefore, this would avoid wasting the heat energy contained. This will now make the clinker cool enough to handle and ready for the upcoming grinding, given that the suitable temperature for grinding should only be less than 100 degrees Celsius. The cooled clinker will now enter another proportioning equipment. A new material, which is gypsum, will be introduced. Gypsum plays a very important role in controlling the rate of hardening of the cement. It controls the setting of cement. If not added, the cement will set immediately upon mixing it with water, leaving no time for concrete placing. The new mixture will undergo another grinding mill. Given that gypsum is added, some parts of it may still be of bigger pieces. They will undergo a grinding mill to break the chunk of materials into smaller and finer pieces. After being heated, cooled, proportioned, and ground again, the exiting product from the grinding mill will now be the cement, which is now ready for storage and packaging. The cement will be stored in a place where they will be staying until they are ready for packaging. Packaging only involves two processes. The first one is the filling process. Here, cement bags made of paper will simply be filled with the cement product. After the filling stage, the still open bags of cement will undergo an airtight sealing process. Here, the bags will be sealed airtight so as not to allow any air to escape or pass through, and of course to prevent any spillage of cement. After packaging, the final cement products is now ready for distribution, selling, delivery, and use. Now let's go to the waste characterization. Generally, in the manufacture of cement, the wastewater quality parameters affected are the total dissolved solids, total suspended solids, pH, BOD or biological oxygen demand, and turbidity. These problems arise due to the particles coming from the unit operation which accidentally combine with the water used to cool the equipment. For the solid waste, there are three main waste produced, which are coal ash, plastic containers, and sludge. Coal ash is considered as a hazardous waste because it contains toxic heavy metals such as arsenic and selenium. Sludge and plastic containers are considered as a solid waste. The water wastes are treated in the water treatment plant, while the solid and hazardous wastes are sent to the materials recovery facility. The wastewater treatment plant is where the wastewater from the previous stages of cement production goes in order for it to be treated before discharge. The processes in the production affected the quality of water, which includes the parameters BOD, TSS, TDS, pH, and turbidity. For the first part of the treatment plant, the wastewater will undergo sedimentation process. This is a physical water treatment which uses gravity to remove suspended solids from water. The wastewater from the cement production is brought to a settling basin, which is a concrete structure, where the sedimentation process is used to remove the unwanted matter. Here, sludge is removed and collected to be delivered to the MRF. The murky water will enter a second water treatment process, which is the multimedia filtration. A multimedia filtration refers to a pressure filter vessel which utilizes 3 or more different media. Here, the largest contaminants brought by the murky water are encouraged to become trapped in the first layer of the filter, with smaller particulates sifting further down into the lower layers. Trapping contaminants in this matter allows for more efficient turbidity removal. Sludge are removed in the filtration process along with the wastewater parameters TDS and turbidity. The filtrate from the multimedia filtration will enter an equalization tank. The main function of an equalization tank is to act as a buffer. It collects the incoming raw effluent that comes at widely fluctuating rates, stores it, and lets it out during a non-peak time, when there is little or no incoming raw effluent. When the filtrate from the filtration enters the equalization tank, hydrochloric acid and sulfuric acid are added into it, so as to neutralize the pH of the water. Therefore, in here, the flow rate of the entering and exiting water is equalized along with the neutralization of the pH. The effluent from the equalization tank now only contains BOD as a wastewater parameter affected. It will undergo the aeration process. The process of aeration is used to mix, circulate, or dissolve air into a liquid, in this case, water. In the treatment, air is added into the effluent, which allows aerobic biodegradation of the pollutant component. It provides oxygen to the bacteria for treating and stabilizing the wastewater effluent. This is because without the presence of sufficient oxygen, bacteria will not be able to biodegrade the incoming organic matter in a reasonable time. After the aeration, the resulting effluent will undergo disinfection process, which is the final stage in the water treatment. This process provides a degree of protection from contact with pathogenic organisms as it removes, deactivates, and kills those organisms. In this process, a disinfectant is used to aid in the purification of the effluent water. Sodium hypochlorite is added as it is very effective for water purification. The effluent coming from the disinfection process now complies with the RA 9275 and is ready for discharge. The materials recovery facility involves 3 operations, particularly sorting, grinding, and briquetting or drying. The solid and hazardous waste such as coal ash, plastic containers, and sludge generated by the different operations of the cement plant will enter the MRF to undergo separation. The solid and hazardous waste will undergo a sorting process wherein the plastic containers of hydrochloric acid, sulfuric acid, and sodium hypochlorite used in the equalization and disinfection process are separated from the other solid waste and hazardous waste. This is done by virtue of gravity, where the waste entering the MRF are placed in a moving conveyor belt with gaps along the track. The sludge, coal ash, and paper waste fall to a container, while the less heavy but larger waste, particularly the containers, proceed to the end of the conveyor belt. These containers are sent back to their respective suppliers to be reused. This will minimize the solid waste being disposed by the plant. More importantly, it will reduce cost for the chemicals used in the wastewater treatment plant, since most companies providing chemicals in containers offers discounts or incentives to those who purchase their products. The sludge, coal ash, and paper coming from the sorting equipment will enter a grinder with a dryer. The wet sludge is heated until dry, to be more suited for the briquetting stage of the MRF. The waste will be reduced into smaller sizes that are suited and necessary for the next operations in the MRF. The output stream of this operation is a mixture of the refined waste that entered the grinder. The ground sludge, paper, and coal ash will enter a briquetting equipment in order to be compact and compressed to a smaller block. The resulting product is called a briquette, which is a block of combustible material. In this case, coal ash and paper. These briquettes are then used as added energy source for the clinker cooler and kiln. By doing this, the solid waste from the MRF are reused for another purpose and will minimize the waste to be disposed from the plant. The cost for fuel to operate the equipment will also be heavily reduced by using the briquettes produced by the materials recovery facility.